Okay, good morning once again, everyone. Today we're going to start our study on panel data. Okay, if you look at if you type sa Google, no, panel data regression using R. Okay, you'll be brought to several sites na which you can use. For example, itong kay Princeton, which I already opened. Okay, so getting started in fixed random effects model using RStudio. I'll share with you this site, okay, so that you can also download this as a reference. Let me put that in the chat box.
Hey guys, and welcome.
Oops, what's that? Hindi mali, sorry. Sorry, that's not the, it's a dapat, no? Ito. Was that the one I shared? No. Okay, this is wrong. In case you did not see this, Control C, Control V. Okay, so this is the slides PDF format from Oscar Reyna from Princeton University. So this is a good reference class. In fact, maybe later in our modeling, let's use some of the codes here. Okay, for example, in plotting the variable of interest with respect to the different cross-sectional units. Okay, so this is the code, right? So quite a lot of codes here. So today we're going to discuss a panel data regression, and this is quite different from the usual ordinary least squares that we have been discussing. Panel data regression involves the use of several cross-sectional units, unlike an OLS where you have you have several cross-sectional units, okay, several individuals taken at one point in time. That's your cross-sectional data. For panel data, on the other hand, you have several cross-sectional units and several points in time. Okay, so that's what we're going to discuss today. And there are three main types of, actually two, but we still include the other one, which is just OLS. So you have OLS, you have fixed effects model, and you have random effects model. Okay, so we're going to study that. And this is very important. This is a very important topic because most of the papers in finance, in the thesis, I would say more than 90% involve panel data. Okay, so it's important that we understand this. So you have several references here. You can of course, let me see. Okay, let me close this. Okay, so this is the reference of, oops. There's also another one. Let me just open this on another tab. And then this one is also, this one is from the text POE. So if I open this is also another reference. Okay, this one. Okay, so let me share with you the site. Oops. There. Actually, this is a textbook. And there are, the topic that we're interested in here is this one, regression with panel data. Okay, this is a whole textbook on econometrics. Okay, for this particular session we're interested in chapter 10 of this reference. So you may of course use this as an additional reference. Okay. So there's no lack as far as references is concerned. So marami, no? Marami. This is also a tutorial. Let's take a look at this. Okay, so these are visualization techniques also in panel data. All right, so you have several references. What I'm using are combinations. So let's open the R file that we were looking at, and maybe also include some codes here that came from the other references. All right. So for today, we're going to look at this. There are some texts here already, which I shared with you. Normally, I don't want to do this, but in the interest of time, I was looking at the calendar and medyo konti na lang talaga yung natitirang time sa atin. So I'm doing this. What I'm sharing with you now has the codes already. Okay. For me, it's not a good practice kasi I would that you write this on your own. Pero because of some constraints, no? All right, so let me just go through the notes that I shared with you here. So panel data analysis, this is one of the most important, especially as far as finance is concerned, because the data that's available to us usually in panel data form. When I say panel data form, you have several units, several identities, several that identity, that unit can be a country, can be a company. Okay, so it can be departments, and the data regarding these units are taken across several points in time. That makes it a panel data. Okay, so there are different types of panel data. Also, we have the wide type, and then we have the long type, which we'll discuss later. The wide type and the long type. So a panel data analysis helps us to analyze your data, okay, both the cross-sectional unit and the time series at the same time. Okay, for example, I stated here that we want to understand the factor affecting rent. So this is what we're going to use, the rent data set coming from the Woodbridge package. So we'd like to look at what affects rent across multiple cities for multiple time periods. Okay, this type of data would be ideal candidate for panel data analysis. Why? You have several units in the form, in this case, several cities, and then several time periods. Actually, dalawa lang. So for the purposes of this example, we'll only have 2 years here, but generally you have several years. Okay. And there's a type of panel data with missing values. So for example, okay, we're studying the, let's say, the effect of COVID on the GDP, GNP of ASEAN countries, let's say from 2015 to 2022, for example, only. All right, let's suppose that in 2015, you have only 3 countries, and then 2016, you have 4 countries, and then 2022, you have, let's say, 10 ASEAN countries, for example, only. That's an example of what we call unbalanced panel. Why? Why is it called unbalanced panel? Because for 2015, there were only 3 countries. 2016, there were 4 countries. Okay? 2022, there were already 10 countries. So that's called an unbalanced panel data. When all the countries are complete, for example, from 2015 to 2022, you have all the complete data. Let's say in 2015, you have 10 countries, 2016, still 10, the same countries until 2022. Then that's what we call a balanced panel data. Okay, so you see the distinction between an unbalanced panel data and a balanced panel data. Okay, So in this so in this study, let's just put in this study, we'll use the rental data. Okay, so this comes from Woolbridge package. Okay, so let's okay, so here I'm introducing, if you have several packages to install, then this function can be a good function. Okay, so first we create an object called package names, and these are the packages that we want to load. So I think there are some packages here which we haven't. Sorry, this should be broom. Kindly correct the spelling, broom. All right, so we won't go into the function, but it just tells us that if if you can see, if there's a package already, any of this package is already loaded. Okay, so you just require it. Okay, okay, so that's what this does, no? So which means that automatic already. So I hope you have run this. So let me just rerun it for purposes of okay, loading required package room. So what happened here? Okay na ba siya? Let me check, no? Library or require. Okay, already loaded. But let me rerun this again. Okay, okay na. All right. So kindly chat, please, if you have loaded the packages and required it, installed and loaded. Okay, so let's wait for the rest. Okay, thank you. Okay, the most important package that we're going to use here is PLM. This is panel linear model. Okay, so far what we have learned is to use LM, the LM function, which comes from uh, base R, I think. Now, if we're working with panel data, we use this function, PLM. So let's first take a look at what PLM does. Okay, let's go to the package section and then type PLM here. Let's just familiarize ourselves with the, okay, naghang lang. PLM. Okay, so let me mas pa rin yan. PLM. Okay. All right. So of course you can download oops, nawawala. Right. I want the package here. Description, user guide. Let's take a look at description. Okay, so PLM See, who are the main authors? Yung mga authors nito si Milo, this is a very delicious family name. Croissant, no? Pagkain, ano? Tape, Tomet, Kleiber, etc. So there are several authors of this. This was released, I think, in 2006. So medyo matagal na tong package na to, no? Hindi ba nakalagay dito kung kailan siya naka-ano? Updated siya. So version 2.6.2 na. Okay, updated siya nung August 2022. Okay, so this has undergone several updates already. Okay, so ito yung package na gagamitin natin. Let me again run this. So these are the functions. Okay, in this package. Marami siyang functionalities. And ito may vignettes niya, no? User guide, panel data, econometrics in R. Let's see this. Natin to. So what happened? Okay, so we have here some write-up, some tutorials. Okay, and in fact, meron dito mga example. Right? So you can just copy the codes here. Okay, so this makes use of the this data set, employee UK, coming from the PLM package. So class you, what I want to show here is that tayo na lang magsasawa sa mga examples. No? So nowadays, it's so easy to really learn models like this in using R kasi maraming tutorials, maraming examples. Okay, I would suggest that you look at this. Ito yung regression, and then learn class from the examples here. So several examples here, tapos andun yung mga answers. You just have to run the code, and the data set is also provided. Okay, so for example, in examples dito, it shows us the different methods as far as panel data regression is concerned. As I mentioned a while ago, there are actually three: yung pooled, yung fixed, at saka random effects. No? Yung pooled, parang OLS lang yun. So we're going to discuss that in a while. All right, so no? So these are references that you can use. Ang challenge lang dito, yung iba dito, matrix approach, no? Pero when you use this already in R, wala nang problema. Okay. Ito kasi yung equation, no? This is in matrix form. All right. Okay, so ito na yung R, no? Okay, so here it's using the library PLM package, and then ginagamit yung these are some of the data sets that's used as an example here. Okay, some here you know already how, of course, you can just copy this, and then you can follow along the examples. Okay, so for our purposes, we'll use another data. Okay, but as I said, nobody's preventing you, class, from really appreciating or understanding more panel data through the tutorials. Maraming tutorials. Okay, so let's use the rental data set coming from Wooldridge. We already loaded Wooldridge. Let's run this. Okay, so andito si rental, ano? All right. So this is rental. Okay, let's just study first. You have 128 entries 128 rows, and 23 columns. Okay, 23 columns. Okay, you notice that some of the columns have many missing values. That's okay, we won't use them anyway. All right, and let's take a look at this. Okay, first you have the city variable. And you notice the city is repeated 1, 1, and it corresponds to a particular year, 80, 90. So apparently this one, how many cross-sectional, how many units do we have here? Okay, so you have 64. 64 units. Okay, so this data is actually, okay, sige, ano muna natin, no? Sorry. Rental. Let's first take a look at rental. Sa help natin. So 64, no? While it's loading, which means there are 64 cities. Okay, wala siya. Ay, naulit lang, sorry. Ano information ng ano? Data? Yan. Nag-seek lang ako ng help, guys. Question mark, Woodridge, the package, and then rental. Okay, so what does this data give us? So Woodridge source collected the data for 64 college towns, okay? From the 1980 and 1990 censuses. All right, so there are 64 individual units here and dalawang years, so 1980 and 1990. Okay, so the data tells us that this is a data frame, 128 observations on 23 variables. So yung city will be the city label from 1 to 64. So 64 cities. The year 80, 1980 or 1990. So this is a panel data class, no? This is a panel data. 2 years lang, tapos 64 cities. Okay, the POP is the population of the city. Enroll is the number of college students enrolled. The rent is the average rent. Okay, and renter occupied units, total housing units, etc. So you have here log of the enrollment, kasama na yung log population, log rent, etc. Okay, so you have several variables here. Tapos y 90. So dito may dummified na siya. No? Here. All right. Here you have a dummy variable already. Y90. So if it's year 1990, 1 siya. Pag year 90 is equal to 1 if year is equal to 1990. All right. So, ibig sabihin yung benchmark natin si 1990. Okay. All right. So that's information about the data. All right. So as I mentioned, maraming columns dito, no? And we have the feature here is that this is a panel data. So we can analyze this using panel data regression. Kasi you have several cross-sectional units and you have 2 time frames. Okay, pag isa lang time frame, Pag kunyari, the data was taken at one point in time, then we cannot use, of course, panel data for that one. Ito kasi dalawa. At least dalawa dapat. Okay, so paki-chat please kung clear so far yung yung fact that this is a panel data. Kung clear sa atin yun. So if you look at any data set, you should be able to identify already panel data to. Cross-sectional lang to. So pag may several points in time kinukuha yung data, tapos you have several individuals or several units. So that's a panel data. Okay, waiting for the others to confirm. It's clear to them this is panel data, that you can identify whether a data is panel data or just a cross-sectional data. On the other hand, by the way, class, if it's time series data, you have only one unit, okay? And the data is taken across several units of time. How about the others, class? Okay, I'm still waiting for 9 who have not responded. Okay, simple lang tanong ko guys, kung clear ba sa inyo kung if you given a particular data, you can identify whether that data is panel data or cross-sectional data. You should, no? You should. So you take a look at the units. Are there different units being considered? That unit or individual can be a country, can be a department, can be a firm, etc. Can be a province in the Philippine context. And then is data taken across several points in time? If yes, then that's a panel data. Okay. All right. So take a look at this function. pdata.frame. What's this used for? I'm having problems with my mouse. Okay. Control C. Okay. Let's take a look first at what this function will do. pdata.frame. Okay, so this is from the PLM package. Huh? Okay, an object of class is a data frame with an index attribute that describes its individual and time dimensions. All right, so it will convert your data frame, okay, into a panel data frame. So you have to identify the index in terms of the unit or the individual and the time dimension. All right, so if you take a look at this, so we're creating this object rental underscore P. Okay, rental panel. So that's just to distinguish it from the rental data set. Okay, before we do this, let's just take a look at the structure of our rental data set. Okay, tagal mag-run. All right, so dami kasi, no? So it's a data frame, okay? It's a data frame, 128 observations, and you notice that the city, okay, integer siya, and the year is also considered as an integer. So it's a data frame, and we want that when we're dealing with panel data, we want the data to be considered as a panel data and not just a data frame. Okay, so this codes, so we're using pdata.frame. The data that we're using is rental, and then we're defining the index is equal to, the first should be your unit or the individual, and the second is the year. Okay, because if we take a look at this, at a rental data set, okay, city is the individual and year is the time frame. No? Kaya we identify the variable city and the variable year coming from the rental data set. Okay. All right. So if we run this, and let's just check ano ba yung structure nitong structure nitong rental underscore p. Okay, let's see this. Okay. All right. You can now see that. Okay. Hindi lang siya data frame, it's also a panel data frame. All right. And then what do you notice also about the index? Ano nangyari kay index class? Okay. Si city, hindi na siya integer. Diba kanina kasi 1, 2, 3, 4, 5, 6, 64 yan, di ba? So it's now a factor. And also your year, ano nangyari kay year? Factor na siya with two levels, 80 and 90. Okay, so that's what happens when we convert a data into a panel data, and the index is converted not into into the type of data it should be, no? Which is factor in this case. All right. So I hope clear to, no? Itong pag-convert natin ng pag-create ng object. It's a different object. Rental panel na siya, rental P, as compared to rental. So we're going to use both. All right. So here I'm creating this object, keeps. Kasi hindi naman lahat gagamitin natin. We're not going to use everything. We're just going to use some of the variables here, because there are some that are missing. Okay, so ang gagamitin lang natin yung log rent, yung dummy variable na 190, yung log population, and then this one, yung log average income, and the percentage of student. Okay, if we go back to balikan natin ulit yung okay, ito. So let's see again what the log population, it's the log of the population, okay? And then L average income, so that's log of the average income. We have the average income here, and then we have the log of the average income. PCT students is the percentage of student population. Okay, so this is, nasa na yung student population dito? Hindi ko makita. So I don't think binigay pa niya yung no? Merong city population. Okay, and then wala yung hindi binigay yung student population, pero binigay lang yung percentage of student population students, which means ibig sabihin ng class that's the percentage of the students over the total population, total city population. Of the total city population, ilan dun yung students, no? So let's take a look at that. So PCT, ito, no? So for city number 1, 20%. So yung buong city population, 20% ng students. So these are what we call university cities, no? Or college cities. These are small cities. Now the main let's say yung pinaka na city na yon is the university. Kaya you can see here that some some have very big student population. Ito 30%. No? Yung iba naman maliit lang, mas maliit, 10%. Okay. And you can see here that over time, ito yung sa City 1, this is City 1, no, 1980, okay, the student population was, again, where's that? Student population in percent. Ito, 20%, and then it became 23% for city number 1. For city number 2, it's 21%, and then it went down to 20. So there were some cities whose student population were going down. Okay, either it may not mean that the number of students are going down, not necessarily. Pwede rin na yung population ng city tumataas. So kahit na nag-i-increase yung student population, mas lumalaki yung population, and that can be seen here in total population. Here, population ng city. For example, this one, 106 naging 141. Kaya grabe yung taas dito, no? Okay? So those are the details. So here let's create this object just called kips, no? And it's a vector of 4 variables, yung log rent, yung Y90, log population, tsaka yung log average income, and then the percentage. So 5, no? Okay, and then we're going to create this object, rental view. Okay, and then sa rental P, take note, rental P is a P data frame, no? Panel data. Tapos iaano lang natin, ang isasama lang natin yung kips. Ibig sabihin, 1, 2, 3, 4, 5. Yung 5 variables lang ang isasama natin dun sa this object called rental view. Okay? So let's see. Let's run this. Let's run this code chunk. Okay. So here, yung view natin, tingnan natin si rental view, ano? So 1, 2, 3, 4, 5. 5 lang yung variables natin. Yung in-specify natin na magiging part of the variable, of the object. And take a look, guys. Itong rental view, notice, indexed siya, no? Ano yung index niya? 1-80, 1-90. Kasi di ba, panel data to, di ba? So we converted. Okay, so we converted si rental, ba, into a panel data, yung rental P. Tapos ginamit natin si rental P so that ang i-include lang niya yung nasa kips. Okay, itong vector na to. Okay, so we created this object called rental view. Ang laman niya si rental P, pero naka-subset lang, kips lang yung laman niya, itong 5 to. Okay? So let's by the way, let's take a look at the tingnan na ba natin yung structure ni rental view? Okay, let's check. Structure ni rental view. Okay, so you can see here that rental view is also panel data frame din yan. Okay, kasi galing yan sa rental, rental underscore P. Okay, so pause ulit ako, guys. Clear so far? Paki-chat naman please kung clear so far yung ginagawa natin, no? So nag-create tayo ng isang object called rental view. Ang laman niya yung mga variables of interest lang. And it's a data frame, no? Okay, so waiting for your response, guys, kung clear tayo so far. If you have any questions about our code so far. Okay? Yung iba, parang hindi nagre-reply yung iba. Are you there, guys? Pa-respond naman, class, please. Let me check kung may questions kayo. Okay. Ito yung disadvantage ng ano ng binibigay ko sa inyo yung code. Mas maganda sana kung kayo mismo susulat. But again, guys, because in the interest of time, no? All right. We already discussed this. Meron siyang 64 cities, no? 2 different years. Okay, and then dinescribe ko na kung ano yung meaning ng mga variables na yan. So summarize lang natin. Okay. All right. So log rent, ito yung yung minimum and then the maximum. Notice si Y90 kasi ano ba si Y90? Structure ni Y90 ito, no? Where's Y90? Okay, asan na si Y90? Hindi ko makita si Y90 ah. So structure, city factor siya, tapos okay, hindi dinescribe si Y90. I-class na lang natin. May problem to mouse ko. Class si rental view dollar $Y90. Okay? Anong class niya? All right. So this is panel, no? Integer siya. Okay, we'll because gagamitin natin sa model tong Y90. All right. So let's first make use of the OLS data. Sabi natin, di ba, there are 3 general methods in dealing with panel data. You have yung nagamit na natin si OLS. Okay? And then you have the fixed effects model and then the random effects model. So, fixed effects and the random effects model. Of course, we will have to check kung ang data natin mas maganda, kung OLS siya, or fixed effects, or random effects. Okay, so we know, based on our previous study, that mas maganda si OLS na gamitin if yung error terms natin are homoscedastic, okay, and then hindi correlated yung mga error terms natin. Okay, so we have to check, no, kung okay yung OLS dito. But usually, madalang ko nakikita na si OLS ang best method sa panel data. Okay, kasi pag OLS, guys, what will happen? In OLS, we ignore yung index natin. We ignore the effects of time and the effects of the different cross-sectional units. So what will happen is that si rental na to, si rental data, i-ignore natin. No? Kaya gagamitin muna natin for OLS si rental data and not rental P, or not rental view. Gagamitin muna natin si rental data, i-regress natin si yung log rent. With here we're studying ano yung mga factors na nag-a-affect ng cost ng rental. Okay? Yung log rent regressed on okay? So regress on the year, the population, average income, and the percentage of students. And we're using the rental data. Okay, ang gagamitin natin yung data frame, no? Yung rental. Okay, so let's run this. Okay, and this is already familiar to you, no? So you have here so significant yung Y90 natin, log population significant at 10%, average income is significant, percentage students are significant. So here we can see that based on OLS, these variables are significant predictors except for log population. Log population, assuming ang ginagamit natin level of significance is 5%, no? 5%, 95% yung level of significance natin, then log population is not significant. Tapos the rest are significant. And we know how to interpret this. Okay, so I will leave that, guys. Okay, and take note, ano to log population to. And then ang ano natin, log rent. Okay, log population, log average income, and you should know how to interpret this already, class. No? Pag dalawang log, so that means that for every 1% increase in the population, there's a what? 4% increase in rental. No? For every 1% increase in population, there's a 0.04 or 4% increase in log rent. Ganun din sa average income. For every 1% increase in average income, there's a corresponding 0.57 or 0.57, that's centavos, no? Or 57%. No? So this has to be interpreted as percent then kasi ang rent natin nakalog. 1% change in average, 1% increase in average income will yield to 57% increase in rent. No? Okay, so by now, class, dapat alam na natin yung pag-interpret, no? Kapag log at saka log, kapag log at saka linear. Okay. Otherwise, guys, you may sabihin nyo sa akin kasi next meeting siguro if you want that reviewed, then i-review natin. Okay, so ang notes natin dito, the OLS ignores the panel structure. Kaya nga ginamit natin yung rental data kasi si rental data, data frame lang yan. So hindi niya in-index si city at saka si year. No? So walang kinalaman, no? We're not making use of the fact that this data is a panel data. So hindi natin gagamitin yung attributes ng isang panel data. So that's the OLS. Okay, and then the multiple adjusted R squared is 85%. All right. And the overall goodness of fit natin, the model itself, F stat natin, 190.9 on degree of freedom 1, 4, degree of freedom 2, 123. Bakit 4? Kasi apat yung predictors natin. Degree of freedom 2 is n minus k minus 1. N natin is 128 minus 4 minus 1. That gives us 123. P-value is practically 0, which means overall goodness of fit natin is significant. Okay, overall the model is able to explain si log rent. Okay, so as far as the OLS is concerned, okay naman, no? 3 variables are statistically significant except for log population. Hindi siya significant at the 5% level. Significant siya at the 10% level. Okay, pause again, class. Okay, so paki-chat naman again kung clear so far or kung may questions. Notice, guys, I'm not really going deep into this kasi Alam naman natin yan, no? Discussion naman natin yan. Kindly chat please if we're okay so far. Okay, how about the rest, please? Seven students not responding. So are you still there? Siguro, let me backtrack. I'm sorry about that. All right. So here, what we're going to do is we're going to use the PLM package. All right. So using the PLM package, we have to define what model we're going to use. Pooling here means it's OLS. It's OLS, and then we have to define here, if we're using the PLM, we have to define the index. First is the unit, and next is the year. But because we're defining it to be pooling, so of no consequence tong ano to, no, yung index na to. Kasi it will be ignored by the function, okay, and then it will just regress it regularly, no? Para hindi niya gagamitin yung panel data. And then this is the result when we run this. Okay, so LPOP, okay. So for OLS here, okay, I stand corrected, guys. It's the same, no? Okay, it should be the same. For a while, I got surprised. Kaso dun sa Stargazer, when we printed it sa Stargazer, now Stargazer yung pulled natin. Okay, I'm wondering why the log population here became 1 star, no? Bakit siya naging significant na at? Okay, this is the difference now. Okay, so let's not get confused, no? For a while, I thought, bakit naging 1 star na siya? So Stargazer is using a different benchmark. So si Stargazer, ang 1 star niya is significant at 10%. Okay, so that we won't get confused, no? I'm not sure if we can modify this to make the 1 star at 0.05. I will have to check that. Maybe you can help me check that. Take a look at the Stargazer function. Okay, but it's the same, only that ito, ang symbol niya, 1 star, is different from the symbol here, no? Dito, hindi siya, ang 1 star dito kasi, here, it's significant at 5%. Okay, ang dot significant siya at 10%. No? Si Stargazer, nung ginamit natin, nung ginawa niyang table yung output, okay, printable table, na maganda yung format. Okay, ang ginamit niya na p-value, 1 star is significant at 10%. Okay, I hope that's clear, guys, so that you don't get confused. But what's important here is that the results of the LM package or LM function, ito, nag-LM lang tayo dito. Okay, LM here. So we know this already. And the PLM function, PLM here, okay, which requires that we identify the index. Okay, let's experiment, class. Okay, sandali ah. And then we identify the model. We get the same results, no? Kasi yung PLM function na to, which is used for panel linear modeling, okay? But using the pooling method, will ignore yung index natin ng city at saka ng year, and then just treat this as one whole data, no? Na parang ano lang siya, parang cross-sectional data lang siya. na isang taon lang. Okay? If I remove the index here, ano mangyayari? Tanggalin natin to, class. Okay? Let's run this. Okay. Nag-okay pa rin siya, no? Okay, nag-okay pa rin siya. Kahit na hindi natin nilagay yung index, class, because yung model nakasabi dito, yung model kasi nakalagay dito na pooling, so hindi niya rin required yung seed at saka si year. Pero this was meant to illustrate that when you're using PLF, in particular, pag fixed effects na at saka random effects, you have to indicate kung ano yung seed, kung ano yung index natin. Okay? All right. I hope that's clear, class. And then we check now now before we check the assumptions, gamitin natin, class, mag-insert tayo dito. No? Gamitin natin, we can mag-plot nga tayo dito, class. No? Gamitin natin yung kay Torres. All right. For example, this one, i-co-plot natin yung, okay. Let's copy this. And na-load ba natin si foreign? Okay, so ano ginagawa nito? Okay, let's just take a look at this because sa paper nyo, gagamit din kayo ng mga visuals, no? Gagamit kayo ng mga plots. So dito yung ano niya, yung index niya, country at saka si year. No? Right, country at saka si year siya. Okay, and then using the co-plot. So y, what's y? Y, ito yung dependent variable niya. So ang gagamitin natin na y, yung ano, yung log rent, no? Yung log rent, ipa-plot natin by year given the country, okay? Line type and okay, let's copy this. Control C. Para may plot tayo ng Control Alt I, Control B, and then I'll remove this one. And then let's change yung Y natin is, dali, yun ko na lang dito. Names. Rental.view lang. Okay. So what am I doing? Class, I'm just copying this para hindi ko na type. Control D. And then you have ang gagamitin natin ang data natin si rental. Tapos city by year. And then given the city. So by year to. Data natin is equal to rental. Okay. What are we doing here? Dito pala city din, no? Ipa-plot natin yung variable of interest natin, si log rental. L-rent din to. Control C, Control D. I-plot natin siya by year, okay, given the city, either a line type or a bar type. So this is bar. Okay. Load muna natin si foreign. If not, class, install nyo siya. And then, i-run natin tong dalawang to. There. Okay, so what do we find here? You can see here the different, given the city, one. Okay, so yung year natin, from 1980 at saka 1990. Okay. And then the different cities. Two, 3, 4, 5, 6. Okay, so okay. So hindi maganda yung lumabas dito, no? Kasi 1, 2, hindi siya clear, no? 1, 2, 3, 4, 5, 6. 80, 82, 84, 86. Ang ginawa niya, nag-incremental siya ng ano ng 2 years. Pero ang value lang niya ng 1980 at saka ng 1990. Okay, so not a very good hindi siya magandang plot gamitin, at least for this data. Okay, then we will have to search for more. So dito kasi sa ano natin, sa data dito, ano ba yung dito kasi may mga ano talaga, may data from 1990 hanggang 1996. So na-plot niya talaga. No? Yung sa atin, class, dalawang data frames lang. No? So hindi siya masyado naging maganda dito kasi dadalawa lang yung ano natin, 1980 at saka 1992. So kinonect lang niya by lines. No? Okay, dito, hindi apparent yung ano yung difference between the line and the bar plot. Kasi masyado nang maliit yung plot natin dito. Okay, so this was not a good presentation. Ito naman by city. Okay. All right. Let's siguro may iba pang way ano. There are other ways to plot the data. Okay, so siguro i-tackle natin next meeting yan, no? I didn't medyo nawala sa isip ko yung pag-plot ng data natin. Pero this is a good way kasi ito you have 1991 hanggang 1990 ito 1996 ba? Yung data niya. Kailangan natin muna i-load yung data, no? Okay. Anyway, so you can follow along this example because this gives us a pretty good plot of the okay, countries. Ilan to? 1, 2, ilan ang countries niya? Country. Okay, we don't have the complete data here, but it looks like na pinaplot yung year given the country. So 7 countries to, no? 7 countries. Country 1, country 2, country 3, country 4. So here we can see the different, different countries. 7 siya. Tapos yung year din niya, 7. No? 7 countries, 7 years. Okay, yung data natin, hindi siya masyadong kita dito. No? There are 64 hindi medyo na ano ko dito. It's not a good presentation. Hindi siya klaro, no? So that's what happens when we have several countries. Ang hirap i-plot niyan, di ba? Cities pala. 64 cities to eh. So ang hirap na i-plot dito. So maybe we can find another function that can. But as it is, class, 64 countries, no? Medyo mahihirapan talagang i-plot yun. Tapos para makita natin yung distinction, okay, medyo mahirap, no? Alright, so sige, let's skip this. Okay, then let's go here now. Alright, let's check if okay yung ano natin, okay yung model natin. Let's do a little bit of diagnostics here. Okay, let's check for the variance of the error terms. Okay, so let's create this object res, and then we're going to get the residuals of the model OLS and also the y hat. Let's create y hat to get the fitted value coming from OLS. Okay, let's run this first. Okay, so we now have this object res, which is a vector. Okay. Okay, it's a vector of the residuals of the model OLS, and the y hat are the predicted values. Okay, so i-plot natin yung dependent variable natin. I-plot natin si, okay, i-plot natin guys yung isang variable natin, si percentage ng student. Okay, which is statistically significant si percentage ng student. I-plot natin yung variable na yan. Okay. So plot natin yung percentage students with the residuals. No? So x-axis natin yung isang independent variable natin. And then sa y natin si residuals, bigyan natin ng label x at saka si y. So let's do that first. Okay. All right. So yung residuals natin dito, no? As compared to one independent variable, si percentage of students. Okay, mukhang okay naman siya, no? Mukhang wala namang notable na variance. Mukhang heteroscedastic, although parang may konting fanning in dito, nagko-congregate yung dito, yung residuals, and then parang numinipis siya, no? Okay, so let's take a look at this time at the i-plot natin on the x-axis si predicted value, on the y-axis si residual. Okay, let's see. For this one, okay. All right. So constant ba yung variance natin? Constant ba? The problem with this residuals is meron siyang nagka-cluster siya. May clustering siya. So hindi siya spread evenly. May clustering dito. May clustering dito, which is indicative na there is heteroscedasticity. Of course, we can test yung there are different statistical tests, which I'll leave that to you, no? To determine. Kasi ito visual lang eh. We can test this statistically kung yung OLS ba natin, yung residuals niya is heteroscedastic or homoscedastic. Visually, makikita natin na may clustering siya, no? In certain portions. Tapos yung kanina, let me once again plot this. Okay. Dito apparent talaga yung clustering, and then siya, it decreases, no? Over the higher percentage of students. Mas maganda, sabi natin, di ba, homoscedastic to, kung spread out yung residuals natin. Dito may it congregates here, no? sa lower values ng percentage of students, okay, nagka-cluster yung ano dito, yung residuals. All right? So this might indicate that OLS might not be the best model to use in analyzing this data. So we now go to the next one. Okay, at least makapag-start tayo ng fixed effects. Then we'll continue with this next meeting. Okay, so si fixed effects naman, ano naman to? Okay, so fixed effects, as the name suggests, may assumption yung fixed effects model. Ang assumption nito, variations within a cross-section, okay, which could be due to the inherent characteristics of that entity, is, so ibig sabihin, class, may variation among the different entities, among the cross-sectional units. So it means that CT1 is different from CT2, is different from CT3, is different from the other cities. Unlike yung OLS kanina, di ba? Yung pooled method natin, walang ano yan, walang sense yung CT, no? We're just using it as one holistic data. So disregarded natin yung CT component, disregarded natin yung time component. As I said, if you take a look at the data, okay, CT1, CT2, CT2. Okay, so could there be a difference between CT1, CT2, CT3? Okay, may mga differences kaya sila? May variation kaya sila among the different cross-sectional units? The cross-sectional units are the individual units. So is it possible that there are differences between CT1, CT2, CT3, etc.? Right, class? So that's the case of the fixed effects. So dito, ang gagawin natin, we will control for the time invariant characteristics. So ano ibig sabihin ng time invariant? What does time invariant characteristic mean? Pag sinabing time invariant, it does not vary over time. For example, kunyari, gender. No? So you're evaluating a data, tapos ang isang ano doon, ang isang variable doon, gender. Okay? So over time, no? Yung gender naman, hindi naman magbabago yan. No? Kunyari, kung hindi kayo dyan male, from 1990 hanggang 2022, that respondent will still have male pa rin yung ano niya. No? Right? Or what else? Kunyari, city born, kung saan siya pinanganak. Okay. Siyempre, this is a good example. No? Yung city born yan, kung variable yan, class, kahit anong year na yan, hindi naman magbabago yan. And this are called your time invariant variables. Those variables that do not vary over time. Okay, so pag fixed effects, kinokontrol natin itong mga time invariant na variables na to. Okay, the difference between fixed effects and the OLS model is changing this model from pooling to within. Okay. All right. So it's already time. I-ano ko lang to guys, and then we'll discuss the results next time. All right. So here, pareho pa rin, no? We're creating this object FE, fixed effect siya. And then we're still regressing log rent. Gusto natin malaman kung ano ba yung nakaka-affect ng rent sa mga cities na to. Okay? And then, gagamitin natin si rental fee. Okay, so since ginagamit na natin si rental fee, which is already panel data, we don't need to index this. Kasi si rental fee, di ba, naka-index na to. Okay, if you recall, okay, dito, balikan ko lang ha. Di ba si rental fee, here, di ba? Naka-index na siya. Okay, but if you're going to use the rental data, then dapat isasama pa rin natin yung index. Okay, just like this. Okay, dito, ginamit sa rental data. Tapos, in-identify natin yung index. Okay, so let's go here. let's just finish this. So dito, class of fixed effects, ang gagamitin ng model is within. Okay, within. Okay, so pag fixed effects, within yan. So let's run natin to. Okay. So notice, pag fixed effects, ano nangyari? We have a different model here, no? Si log population, hindi na siya naging significant. Si percentage of students, naging significant siya. Okay, so magkaiba, no? And the R squared is higher for the fixed effects model as compared to yung sa OLS natin na ano yung adjusted R squared niya, hindi nakalagay ito, 85%. But then again, hindi natin pwedeng sabihin na mas maganda na kagad si si fixed effects by virtue of the higher adjusted R squared. Okay? We will have to test this, okay, and we'll be doing that next meeting. So ang na-notice natin, iba na yung significant dito, no? Okay, dito, wait, log population, okay. Yeah. Sorry guys, what I meant was, dito, yung p-value ni log population is 0.07. Significant siya at 10%. Pero dito sa sa fixed effects natin, okay, yung p-value niya is really very high, no? So malayo siya dun sa sa OLS. It's still not significant and very not significant. Tapos what about the estimates? Are they the same? Kunyari itong log average income 0.3099 dito sa OLS, it's 0.57, no? Average income. So medyo may difference na itong OLS natin at saka si fixed effects model. All right? It's already time, class. So we're going to continue with this next time. Next time, okay, i-run ko lang quickly to, no? And then paki-alam kung anong ibig sabihin na yan. Anong yan nangyari dito? Bakit nagkaroon ng ganyan? All right? Yung fixed effects na yan. Kasi hindi pinakita dito yan sa output. But in fact, meron yan. Hindi lang pinapakita dun sa fixed effects model. And what do this mean? Ano ibig sabihin yan? And the next meeting, tatapusin natin to. We're going to compare the fixed effect and the OLS. And then we're going to check another method, random effects. And then we're going to see what is the best method among these three. All right? So let me Okay, so thank you so much, class. We'll see each other on Friday.
Thank you, sir.
Okay. Pakibasa naman yung mga references natin, yung yung katulad ng si Oz, si Torres, no? Para makakatulong sa inyo. No?
Okay. Hello, sir.
Yes.
Can I quickly consult something with you lang po?
Okay. Pwedeng na lang, pwedeng later this afternoon. Kasi may class.
Through what po, sir?
PM mo na lang ako, ha?
On Canvas po or?
Hindi, sa Messenger.
Oh, sa Messenger.
PM ko kasi
okay.
may class na ako na 9:15, no?
Okay po.
Okay.
Thank you, sir.
Thank you. Sige.